Hello everyone, myself Heli Mehta, working as an assistant professor in Computer Engineering Department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Our subject is Computer Network. Our unit is 4, that is Network Layer. So today our topic is Routing Information Protocol, RIP. Okay, so RIP stands for Routing Information Protocol. The Routing Information Protocol defines a way for routers which connects network using the internet protocols to share the information about how to route traffic among the network. Okay, so routing information protocol is define a way for the routers, okay, which are connected network using the IP protocol. So routers are connected using internet protocols, okay. Between them they share the information about how to route the traffic among the network. So this is the functionality of routing information protocol. Each RIP router maintains a routing table, okay. So each router maintains the routing table always, which is the list of all the destinations, okay. In routing table we have a all destination where we want to send the package. It knows how to reach along with the distance to that destinations, okay. So along with the distance from A to B we send to packet, then A is the source and B is the destination. Between them it is a distance, okay. So in routing table we have a list of all destinations with the distance, okay. So RIP uses a distance vector algorithm that I have explained in the previous lecture to decide which path to put a packet on to get to its destination, okay. So RIP uses distance vector algorithm to decide from which path we send the packet to that destination, okay. It stores in its routing table the distance for each network, okay. So distance for each network is stored in the routing table. It knows how to reach along with the address of the next hop router, okay. Another router that is on one of the same network through which a packet has to travel to get to the destination. So whole path is okay. So routing table in routing is stored in the routing table the distance for each network, okay. It knows how to reach along with the address of the next hop. Next hop means next node, okay. So from source to destination it provides the path, okay. If it receives an update on a route and the new path is shorter, okay, suppose we select some path A to B to C to D and we get another route that is the new path and it is a shorter, okay. It will update its table entry with the length and next hop addresses of the shortest path, okay. So if we found the shortest path, then it will update in the routing table, okay. If the new path is longer, it will wait through a hold down period to see if later updates reflect the higher value as well, and only update the table entry if the new longer path is stable, okay. So if the new path is shorter, then it update the routing table, and if the new path is longer, then it will wait through the hold down period, okay. Using RIP, each router sends its entire routing table to its closest neighbors, okay, every 30 seconds, okay. The neighbors are the other routers to which this router is connected directly, that is the other routers on the same network segments this router is on, okay. So in RIP, suppose after A we have a node B. So node B is directly connected with node A. So node B is a neighbor of node A, okay. So in RIP, each router sends its entire routing table to its neighbor, okay. The neighbors in turn will pass the information on to their nearest neighbors, okay, and so on, okay. So after B we have a if we have a node C, then node C is directly connected with node B. So node C is a neighbor of node B. So after getting the routing information, node B send the all information to node C and so on, okay, until all RIP hosts within the network have the same knowledge of routing path, a state known as a convergences, okay. So if we have a 5 nodes and then from A to B, B to C, C to D, D to E, routing information is passed, okay. So this is the RIP message format. So first we have a command, then we have a version, then we have a reserve here we have a family, here we have a all zeros, then network address, all zeros, all zero, and distance. So remember this diagram, this is the RIP message format, okay. So first is command, this is a 8-bit field, specify the type of message, 1 for request and 2 for respond, okay. So here we have a command. Okay, so command is a 8-bit field, and there are two types. If it has a 1, then it is a request command, and if it is 2, then it is a response command. Okay, response command. Version, this is a 8-bit field, define the RIP version. It define the version of RIP. Family, this 16-bit field define the family of the protocol used. For TCP IP, the value is 2. Okay, so it define the family. Okay, we use TCP IP. Address is 14 bytes, define the address of the destination network. Okay, so network address. Okay, it define the destination address. Next is distance. This 32-bit field define the hop count from the advertising router to the destination network. So how many hop they have to travel from source to destination, that is the distance. Suppose A to F we have to travel the packet. Okay, so from A to F how many nodes are in between. Okay, so that is the distance between source to destination. Okay, so RIP uses two type of message. Okay, that I have explained here. Commands, two messages are there. Okay, request and response. Okay, so this is the request for some and this is the request for all. See here, request message. A request message is sent by a router that has just come up or has some timeout entries. It can ask specific entry or all entries. Okay, so a request message is sent by a router, okay, that has just come up or has some timeout entries. Okay, they have a timeout. It can ask specific entries or all entries. Okay, so if we have a specific entries, then we have a this diagram, and if we have a request for all, then we have a this diagram. So this is a command version, reserved, family, all 0, network address, all 0, all 0, all 0. Okay, now request for all, then we have a command here we have a 1 value, that is request, that I have explained over here. If we have a 1, then for request, and 2 for respond. Okay, so this diagram. Okay, so here command 1, so it is the request message. Version, reserve, family, all 0, and for request for all we have all zeros, and for request for some we have a network address. Okay, so we have to provide the address of for which we are requesting. So this is the difference. Now second is response message. The response message can be either solicited or unsolicited. Okay, a solicited message response, it send only in answer to request. So suppose we get a request, then we have to only send the response. Okay, contain information about the destination specified in the corresponding request. Okay, it will provide the information about destinations. Okay, and unsolicited response, it send periodically, every 30 seconds it send the response. Contain information about the entire routing table. Okay, in solicited we have only information about destination. Okay, here we have a information about whole routing table. That is the difference. So response is always given after we get the request, so it send only in the answer to request. So if we have a request, then we are providing the response. Okay, so RIP uses 3 timers. Okay, periodic timer, expiration timer, and garbage collection timer. So timers are periodic, so 25 to 35 seconds, expiration 180 seconds, and garbage collection 120 seconds. Okay, so periodic timer control the advertising of regular update message. Okay, so it control the regular update message. Although protocol specified 30 seconds, the working model uses a random number between 25 and 35 seconds. It prevents router update simultaneously. Okay, this is the periodic timer. Between 25 and 25 seconds we have a random number. Expiration timer govern the validity of the router. Okay, so router have a validity set to 180 seconds for a router when a router receive update information for a route. Okay, if a new update for a router is received, the timer is reset. Okay, in normal operation this occurs every 30 seconds. So if we have a new update okay, from router another router, then this timer is reset. Okay, and in normal operation this occurs at every 30 seconds. If timer goes off, the router is considered expired. If we didn't get any update and after some time your timer goes off, then the router is considered as expired. The hop count of the router is set to 16, which means destination is unreachable. Okay, so this is the expiration timer. If our timer goes off, we consider this router as expired. Okay, next is garbage collection timer. When a route becomes invalid, okay, we have a multiple route, and if our route is invalid, the router does not immediately purge that root from its table. Okay, immediately it will not remove. Okay, it continues advertise the root with the matrix value of 16. Okay, immediately it will not remove that root from the table. A garbage collection timer is set to 128 seconds for the root. Okay, we have a 120 seconds for garbage collection timer. When the counter reaches to 0, okay, 120 to 0, the root is purged from the table. Okay, so when timer reaches our count is reaches to 0, then and then this invalid root is removed from the table. Allow neighbors to become aware of the invalidity of the root prior to purging. Okay, so suppose from A to destination E, one root is invalid, then after A's neighbor is B, then B is aware of the invalidity of that root. Okay, before we remove the root from the table. So this is the garbage collection timer. Okay, so these all are the RIP timers. Okay, we have a two type of message, that is request and response, and this is the RIP message forward. Remember this diagram. Okay, so this is the RIP routing information protocol. Thank you.